this video, we will be discussing about course schedule 4. There are a total of num courses you have to take, labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites of I is equals to AI comma BI indicates that you must take course AI first if you want to take course BI. For example, the pair 0 comma 1 indicates that you have to take course 0 before you can take course 1. Prerequisites can also be indirect. If course A is a prerequisite of course B and course B is a prerequisite of course C, then course A is a prerequisite of course C. You are also given an array queries where queries of j is equals to uj comma vj. For the jth query, you should answer whether course uj is a prerequisite of course vj or not. Return a boolean array answer where answer of j is the answer to the jth query. So what they are saying is that in the input, we are given this num courses integer which denotes us that how many courses do we have. Then we are given this prerequisites array which denotes that for taking course 2 we need to take course 1, right? So basically a comma b is denoting that for taking course b we need to take course a. Basically course a is a prerequisite for course b, right? And then we are given this queries array which we need to answer. For each of these queries we need to answer true or false on the basis of whether this particular course is a prerequisite for this course or not, right? So basically if 1 is a prerequisite for 0, then the answer for this query will be true, otherwise false, right? So basically we need to answer all these queries and that array which will be the answer of these queries that we need to return as our answer, right? So as we can see over here, we can draw this in the form of a graph. First one was that for course 2, 1 is a prerequisite, right? So this is course 1, this is course 2. So for taking course 2, course 1 is a prerequisite, right? Then for course 0, 1 is a prerequisite, right? And then for course 0, 2 is also a prerequisite, right? So that is how we have formed this type of graph over here. Now if we try to find out the answer of this query, so what is it asking? That for course 0 is 1 a prerequisite? So we can see that yes it is. So the answer of this will be true. And if we check for this one, that for course 2 is course 1 a prerequisite? Yes it is. So the answer for this will also be true, right? So basically you will return a two length array containing both the values as true in your answer, right? So this is what the question is asking us to do. Now, how are we going to solve this, right? So see here, this graph and the queries are little straightforward. So we won't be able to identify all the scenarios. So let me take some other example through which we can understand better. So if let us suppose that our graph looks something like this. So here, if you see for course 1, the prerequisite is course 0 and course 2. And for course 3, the prerequisite is 0, 2 and 1. Right. Now here, they are mentioning one more thing, that there is an indirect relation as well. For example, for course 3, 1 is a prerequisite, but course 0 and 2 are also a prerequisite, right? So basically, if for course B, A is a prerequisite, and for course C, B is a prerequisite, then for course C, A is also a prerequisite. This is what they have mentioned in the question. And that is the reason if you see over here, for course 3, the prerequisites will be course 0, 2 and 1, right? So this is also we need to keep in mind, right? So now how are we going to solve this is that one of the possible approach or the brute force approach is that you take each of the query and you run a BFS over here or a DFS and try to identify whether that particular course will be a prerequisite or not. And then on the basis of that, you can identify the answer as true or false, right? But as you know, that will be inefficient. Why? So see, you will either apply BFS or DFS for each of the queries, right? So basically, if the total number of queries are Q and then you will be applying BFS, then it will take V plus E time, or I should say n plus e time, right? This n is the number of nodes and e is the number of edges, right? Now, in worst case, the number of edges can be n. Why? Because this course 0 could be a prerequisite for all other nodes, right? This right now it is the prerequisite for course 6 and 1, but it could have n minus 1 number of edges over here, right? It could be a prerequisite for all other nodes, right? So in that particular case, your number of edges in worst case can go to n, right? So it will be somewhere around q into n square. This will be our time complexity if we follow the brute force approach, right? But this is not going to work. Why it is not going to work? Because n is given to us at max 100. So it will be 100 square, and q is given to us as 10 to the power 4. So 10 to the power 4 and 10 to the power 4. So this is not going to work, right? We'll have to optimize it. So let's see how can we do that. So in the brute force approach, what we are doing is that we are taking each of the query and then we are running a BFS or a DFS over here to identify the answer for each of the query, right? Instead of this, we can do some pre-computation. What type of pre-computation? That we can identify it beforehand, that for which course, which is the prerequisite, right? So basically, what we can do is that here we are having 7 courses, right? 0 to 6. 7 courses we are having. So we can create an n cross n array or a vector, basically a 2D vector of size n cross n, right? So it will be of size 7 in this particular case, right? So let me create it. It will be 0, 1, 2, 3, 4, 5, 6, and then here 0, 1, 2, 3, 4, 5, 6, right? Now initially in this 2D vector we can keep all the values as false, right? Now what you can simply do is that you can apply BFS for each of the nodes in the graph, right? You can apply BFS for each of the nodes and you can mark it here that for which node which is a prerequisite, right? So what we will do is, as I said, we will apply BFS for each of the node. So we will run a for loop of I, right? And this for loop will start from 0 and it will go till the last node, which is node 6, right? And then for each of the node, we will be applying BFS. And for BFS, we will obviously be taking a queue, right? So when our I is at 0, what we will do is that we will push node 0 into the queue, right? So node 0 will be pushed, and then what do? We run a while loop that while our queue does not become empty, right? What do? We take the front node from the queue. So 0 will come out, right? And now we will check its adjacent elements, right? So basically in the question you are given a prerequisites array, right? So obviously you will have to create an adjacency list for that, right? So that we will see during the code, how are we going to create the adjacency list, right? So through that adjacency list, you will identify that for 0, what are its adjacent elements. So its adjacent elements are 6 and 1, right? So what we will do is that in this particular vector, add this 0, right? For 6 and 1, we will see it would be false right now. So we will make this as true and then we will push 6 and 1 into the queue, right? So now in the next iteration, this 6 will be taken out from the queue, right? And now for 6, do we have any adjacent nodes? No, right? So next 1 will be taken out. So for 1, do we have any adjacent node? Yes, we have 3. So in this row 0, add 3, we will make it as a true, and then 3 will be pushed onto the queue, right? Now for 3, do we have any adjacent nodes? No. So this 3 will be taken out and our queue will become empty, and now we are done for node 0, right? So if you see that node 0 was a prerequisite for 6, 1 and 3, and that is what is marked over here, right? Now we will do the same thing for node 1. So for node 1, 1 will be pushed over here. In the first iteration, this 1 will be taken out. The adjacent node of 1 is 3. So we will mark here it as true, and then 3 will be pushed. Then 3 will be taken out. 3 is not having any adjacent nodes. So the queue will become empty. And now we will move to 2. So node 2 will be pushed. Now for node 2, we will start the BFS. Node 2 will be taken out. Its adjacent node is 1. So here we will mark it as true, and then 1 will be pushed over here. Then 1 will be taken out. 1's adjacent node is 3. So at index 2, we will mark true over here under 3, right? And then 3 will be pushed here. Then 3 will be taken out. 3 is not having any adjacent nodes. So the queue will become empty. Then we will move to node 3. Node 3 will be pushed here and then it will be taken out. Node 3 is not having any adjacent elements. So the queue will become empty. Now we will move to node 4. So 4 will be pushed over here and then 4 will be taken out. The adjacent node for 4 is 5, right? So in this particular row at 5, we will mark it as true, right? And then 5 will be pushed over here. Then in the next iteration, this 5 will be taken out. 5 is not having any adjacent nodes. So the queue will become empty. Then we will move on to 5. 5 will be pushed here. It will be taken out. 5 is not having any adjacent elements. So the queue will become empty. Then we will move on to node 6. Then 6 will be pushed over here. 6 is not having any adjacent nodes, right? When it will be taken out. So the queue will become empty. And now we are done with all the nodes. And this is what our 2D vector looks like. Now this is telling us that which course is a prerequisite for which course, right? So now you can answer all of your queries in constant time, right? So if I ask you that is course 4 a prerequisite of course 2, so you will check this value. So this value will be false, so you can return a false. Then if I ask you that is course 2 a prerequisite of 3, so you will check 2 and then here 3, so this value is true, so you will return this true, right? So this is how we can answer each of the queries in constant time, right? So now here what will be your time complexity? So if you see that first of all we are applying BFS over here for each of the nodes, right? So as I said that the BFS will take n plus e time, right? This e can in worst case go to n, right? So as I said that the BFS will take n square time, right? And this BFS traversal we are applying for each of the node in our graph, right? And the total number of nodes are n. So that will be into n. So it will be total of n cube, right? And then we will be identifying the answer for each of the queries for which we will be running a for loop equal to the total number of queries. So it will be plus q. So this will be our time complexity, n cube plus q. Now since n was 100, so 100 cube plus 10 to the power 4, this will work, right? Earlier this q was multiplied but now it is added, so that is why this will be accepted, right? And space complexity wise if we see, so we will be creating an adjacency list, right? So which will take n square space because edges can go to n, right? And then we have taken this particular vector which is also of n cross n, that is n square, right? So the space complexity would be order of n square, right? So now actually there are other approaches for solving this problem as well, right? We could also apply DFS or we could also apply the concept of topological sort over here, but in each of them the time complexity and the space complexity is going to remain the same, but this is the most simplest efficient approach that we can follow, right? So now let us quickly look at the code. So first of all, we will create our adjacency list, right? So for that, we can take an unordered map. In this, the key will be an integer and the value will be a vector, right? And let's name it adjacency list, right? Then what we will do is that we will run a for loop inside our prerequisites vector, right? And this will give us all of the edges that we have in our graph, right? So for auto edge in prerequisites, what we will do is that in the adjacency list, where are we going to push at edge of 0, we are going to push back edge of 1, right? So this is how we will create our adjacency list. So now that we have done this, we will do the pre-computation of applying BFS for each of the nodes, right? And for that, we need the 2D vector which we were updating as true or false, right? So that 2D vector we will create vector int, let's name it is prerequisite, right? So this is telling us whether a particular course is a prerequisite of some other course or not, right? So now what will be its size? As I said, it will be n cross n, that is num courses into num courses. So num courses comma vector, actually this should be boolean because we will be storing whether it is true or false, right? So vector bool num courses comma false. Initially we will keep all the values as false, right? And then we can create a helper function for applying BFS for all the nodes, right? In that helper function we will pass the total number of courses that we have, and then we will pass our adjacency list, and then we want to pass this 2D vector that we have created, right? And we will pass this 2D vector by reference, so it will actually update this particular vector only, right? So once this is pre 2D vector has been updated, we will answer our queries. For that, we will create a Boolean vector, which will be our result that we will return, right? And then we will run a for loop that for auto q in the queries, right? Inside this, in the result, what are we going to push back? We will check in the is pre vector that what is the value for q of 0, comma q of 1, right? So whether it is true or it is false, it will be pushed back into the result, and at the end we can return this result, right? So now let us write this helper function. So this is not going to return us anything, and it is receiving the total number of courses which we can take as n over here, and then it is receiving the adjacency list, right? And the next thing that it is receiving is the pre vector which we will pass by reference, right? So this is what it is receiving. Now inside this, as I said, we will be applying BFS for all the nodes. So we will run a for loop of I starting from 0 till less than n, and then we will do I plus plus, right? And then inside this, we will create a queue which will store integer. We will name it queue, and in the queue, we will push this particular node I, right? And as we have pushed this, now we will start our while loop, that while our queue is not empty, what do? We take the front node, right? So this will give us a node q dot front, and then we will pop it. So q dot pop, right? Now what do we want to do is that we want to check its adjacent elements, this particular node's adjacent elements, right? So we will run a for loop, that for auto adjacent in the adjacency list of this particular node, right? We will check that if in the is pre-vector, if this value is false, right? If this value is false, only then we will push it, right? Because if it is already true, then that means it is already marked as true, right? We do not need to mark it as true and push it into the queue again, right? So if it is false, only then what are we going to do is, firstly, we are going to update it to true, right? And then we are going to push this adjacent node into the queue, right? So this is what we will do, right? So let's try to run this now. So the test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.